Hi, I'm Blaine Lewis, founder and director of New Approach School for Jewelers, located just outside of Nashville, Tennessee. And today I'm here with my friends at Rio Grande, and we're shooting a tips and tricks video where we'll show different little adaptations to burrs and tools that can make your life at the bench a little easier. I hope you enjoy. So what I'm going to show is some information about heart burrs, and just want to take a little dive into a heart burr. Like almost all of our bearing cutting burrs, they have directional teeth. So if you look here, you can see that there's a direct, distinct angle to one side of the teeth. So these are almost have like a tractor tire grip one way. They don't have a lot of grip the other way. A couple years ago, I just was playing around, and I got a big surprise. If you run a heart burr backwards, it'll still cut. It's not as efficient, it's not as fast, but one thing it does is it takes out sometimes the horrible traction effect of the burr and then the preceding wrap around the burr that can just be so damaging and kind of frustrating to us as stone setters. So let me show you some neat things about this. Just going to show on a toothbrush for a second, just to kind of just further demo a little bit about what I'm talking about, so you have no mistake about direction and so on. So if you look at the burr this way and turning normally right, it's got an awful lot of traction and grip and cut. Okay, so today's modern flex shafts and all the micromotors, almost all the micromotors that I know, have reverse setting on them. And so if we put our flex shaft or micromotor in reverse, what we get is very little grab, but yet it still cuts. So let me show you this on metal. So I'm going to do some prong cutting on this mounting. These are fairly robust prongs. And here's an orange CZ we'll put in it. And so in doing this cutting, I'm going to run through just a little simple kind of the proper place for the stone to be set at. What elevation on the prongs is proper for this to be set at? Some of that is in the eye of the beholder, and it certainly you certainly must take into account the cullet sticking out the bottom. And in this mounting, there's no danger of that. I normally go by what's called a rule of thirds. So I take the pavilion of the stone and divide it into thirds. So I would have the upper gallery wire, so to speak, or the top of this mounting here, I would have that hit at about a third down from the girdle, leaving 2/3. So that would put it at an elevation that looked something pretty close to that right there. Okay, so having picked that elevation, I'm going to go in and I'm going to use the burr in absolute reverse. You can kind of see it on my skin too, that it just doesn't have that much traction, running backwards now. It feels funny on the finger because the way it wants to pull the skin is so different. But besides that, the controllability of it is just really good. So there's one seat. Let's cut another. It's good for a rough end. I'm going to cut about a third into these prongs. This stone is just slightly undersized for what it could be. But like most mountings, you've got a variable, and this is certainly within that scope. Speed is another thing. I think that not enough is talked about on the proper speed to operate a burr. Machinists go by a chart that calculates the size of the cutter and the feed rate. For us, we're having to do this all by hand feel. And for me, you got to realize you have to feel the fact that you've got to operate the burr for its size at a speed that will cut. Little burrs have a very small linear outside dimension, so they run faster. Bigger burrs don't need to be run as fast. So you just kind of play with the foot pedal until, like right now, I'm not doing a whole lot. Speed up a little bit, and I'm doing considerably more. So it's a constant assessment in the way the burr is cutting. I've seen burrs that begin to cut well, get a little clogged in metal. If you vary or change the speed of what you're doing, partway through the process, it'll start to cut better. It is definitely something that you should have a tactile read, a feedback from, and how you feel like it's doing, and experiment and try other things. Okay, so getting a little closer, but you can see this cuts. If I didn't tell you I was running backwards, you wouldn't know. Fairly efficient. So even in the pavilion angle, I'm going to tip the pavilion angle back a little bit. I'll raise this bearing up a little bit, I believe. I've got some thicker girdle to compensate for. But I'm going to look at the pavilion angle, and it's pretty close. I'm going to tip it back just a teeny bit, just this one side. Big thing with this, and in the first tips and tricks video we shot was all on Burr Control. There's a lot of information about a lot of subtle technique about how you hold the burr properly. All right, so one of the things I do before I want to start pulling back prongs to check the fit is let's visually check the fit. Let's use a good loop or a microscope. Stone setting is something that definitely goes beyond the optivisor for most situations. And you can optically see this here, that these guys line up pretty good and should be a pretty decent fit. The bearing on the right side right here is a little shallower than the other. As we turn it, probably show a little deeper. That just tells me I need to push this a little bit to the one side and just to do a little bit more. Turn it this way, that looks better. I'll take a pair of pliers and pull this back. Ease the prongs back a bit. Check to see whether this will slip in. Not quite. May require 1 or 2 more cycles. Don't want to push it out any further than I have to. So just using a pair of chain nose pliers. Ease these back. Some might take 2 prongs and pull them way back and leave the other 2 alone. I'm not partial to that as much, unless there's real circumstances about the design of the ring, and in one way it's very difficult to move them. So this has gone in now, and before I go, it's always you want to see it set. So you look at it, and if it looks right, you want to push it up. But I want to do a little inspection on what the girdle actually looks like. So you could have, this stone could have been set with a setting burr, and then all metal forged over in some manner on top of the prongs. It is certainly one of the staples of stone setting, but if you can master your burr control, this is a method that I use probably 80% of the prongs that I do. It just has it's faster, it's more efficient, there's less acute bending of the stones. There's a lot of good benefits to this. But one of the things that can be just a little bit trying is that if you do have a heavier girdle, the heart burr is going to give you the same cut every time. Now you can manipulate that cut a little bit, and you can raise the heart burr slightly, and that will give you a kind of a small flat right there. If you do, a lot of times that gets a little dangerous. So I'll show you a real simple way to alter that. So if you look on the left side of this CZ, you can see that definitely that the girdle is thicker than the profile on the right. So I've seen a lot of things that people do to alter this, saw blades, all kinds of stuff. One of the simplest, cleanest ways to do it is to use what's called a crosscut burr. This is not a Krause burr, which is probably much more common burr. I'll show you both and the reasons why I like the crosscut in this manner. This is a tapered crosscut, so it gives me some varied sizes that I can use comfortably. This is a Krause burr, and it has the look of an elongated medieval spear almost. It's very, very sharp, and it's found my finger more times than I'd like to admit. This is a crosscut burr, and the crosscut burrs come in smaller sizes. So let me put them side by side here a little bit for a more fair kind of a up close. So a lot more variance in size on the crosscut and smaller. So what you'd want to do, what's really most important is how is the size of that burr compare to the profile of your girdle. And for me, the tip of this is about just right. And that's going to help me to go in and adjust this on this side just a little bit. Controlling the burr, real simple with this, because we're going to go crossways, which means we don't suffer prong runaround with this to not at all for this, but you can run up the face of the prong this way a little bit, but it's not anywhere near as likely. So a little touch of this, and that, if I can get in close enough, causes just a mild shoulder effect, just a very mild shoulder effect right there. What's so nice about this, and I use this for altering if I have to set a cab in a prong or something like that, this is so nice where you can just pull down and you can come on the fly, change and take that shoulder effect off. So let me show you again. It's both a little heavy on this side right here too. So for a clear vantage point of what I'm doing, it's this way. You can see what's happening as far as the orientation of the burr, but it's this way that we see the actual silhouette of what's being removed from the prong. So this is good right here, and then just a little shave down to take that shoulder effect off. Okay, now the other two prongs could probably use a little adaptation, but let's just see what this looks like now. It's a little softer. I believe that fit is nice. I'm going to do just a little bit more on the bottom, on the pavilion side. I'd like to see it set up in there a little bit more. That's better. That's better. Okay. So now, a simple technique for setting prongs like this, as far as bringing them forward, is to take a pair of pliers, and I like to hold my pliers in such a way that they're actually coming out the end of, they're aligned with the end of my thumb in the same way I might use a graver. So I am not a fan of holding pliers in this method right here, because for a lot of prong setting, it puts your strongest fingers, your pointer finger and your middle finger, at the longest point of the leverage factor of the pliers. And it's coming out the bottom of the hand. I really prefer a hold like this as far as being able to control the pliers much greater. I have less slippage in doing that. So what I'm going to do is bring these prongs up in opposing sections. So it'll be like this. Try to bring them up evenly, and that can be controlled by tipping the the plier angle down a little bit if I want to push the prong that you see here on the right more than pushing the left. That can be altered very easily by doing that, and if I come up a little higher, it's definitely obvious which way I'm going to go with it. Now I'll bring it back a little bit because I really didn't want to go that far. And then we'll come forward with these. You can see me shifting the stone a little bit because it needs to be shifted. Get to bring a support here, bring this prong over a little bit. This one's a little shy in its bearing, but just bring it up just a little bit. Okay, and now I'll start to kind of clean up, get some beeswax off of this, do a better inspection of what's going on. I've got my stone is set. I want to show you some things about when you have, say, a stubborn prong that doesn't want to go over as much. A lot of times when you go to push and you get to the point where you're touching, but you just would like to bring the prong metal down a little bit more, and you can simply grab the prong by its side a little bit. You actually begin to alter the grain boundaries of the metal, and you get it to move in a way that just straight on pressure doesn't provide. There's a lot of information about that in the Princess Cut video on just how to move difficult prongs. If this was a true fragile colored stone, I certainly would not use cutters like I'm going to do now. But this is, you know, on a sapphire or a ruby or a diamond, or some other things that are a little tougher, I wouldn't have problems with this. Many people don't think about this, but the shock involved in cutting, I think, is a little bit dangerous. So I'll place my finger over top and cut these back to something as far as a reasonable height. And I'm going to leave one of them up because I'm going to show a new cut burr that is just one of the funnest things that I've seen in a while. It's just so great. So I'll leave this one up. So I cut those back to what I think is an appropriate angle. I don't like prongs that tower or even anywhere close to tower over top of the table at this size stone. This is a 6 millimeter, 3/4 of a carat stone. So for that, normally my prong tips are somewhere close to 70 or 80% of the overall crown from girdle up. So right here, that's about where we are right now. It'll get a little bit lower as we clip it. So going into finishing this up, I want to show you something that's just really fun. This is a new product by Bush, and these are called the Twin Cut Burr. So most cut burrs have teeth inside that are similar to any of the heart burrs or setting burrs. They have a fantail array of teeth, okay? And those cuttings stay packed inside the cup. It leads to clogging. It doesn't cut very efficient. This twin cut is a burr that just has 2 slots in it. And I have to admit, when I first looked at it, I went, I can't see where this is going to be very effective. The thing that I just demonstrated in clipping the prongs, for a lot of prong situations that would be, let's say, not as tall as this, I wouldn't reach for the file. I wouldn't reach for the clippers. I would actually reach for this now, because this actually pulls metal off at a very fast rate. Does not have to be run fast for the burr. So let's take a look at this. So here's the cut burr, and after I get a little bit of lube off of it, let's watch what this is doing. I want you to see the spirals coming out of that. If I can back that up a little bit. There's just these, it looks like the best drill bit spirals that you'll ever see come out. And it shortens the prong down right before your very eyes in a very efficient manner. So this has to be rotated a little bit. I'm going to get a little smaller burr. It's a little bit big. How do you size the burr up? Well, in many cases, you know, you kind of look at it like a baseball cap that you put on your head. If you size it up, if it was a child's cap, you would immediately look at it and know it wouldn't fit. These sizes are really, really close, so they give you, they don't pin you in. There's a lot of versatility here. So in rounding a prong, it's good to kind of rotate a little bit, but this brought a prong that needed to be cut down in just seconds. I'm going to demonstrate it again with a different version of this burr. They have a very slimline version of it that's coned. So that works terrific, gives you a nice round top, pulls it down to a good height. I'll touch one across from it, right next to it. It happens, you'll when you go to use these, if you're new to them, you'll have to use them slow and very, just really take your time, because it is amazing how quick this thing goes. So what I'm saying by take your time, with pressure and speed until you get to know it. When you get to know it, you'll fall in love with them. They're just one of the best new tools I've seen, okay? So you might notice just a little of an overhang on the one. The one that was taller, I didn't shorten it all the way down. There's just a little, say, you know, place where hair might catch or something like that. So I want to show you a little tricks on this. Many times the answer is not always to reach for something to remove, but it's actually to kind of burnish down that edge is the better way to go in most cases. I'll show how to make this tool coming up. This is one of my favorite little tricks. It's called a micro needle burnisher. So it's nowhere near as, it's much more sharper than the needle burnisher used for flush setting. So if you were to look at this burnisher against something this is a GRS rubber handle. This is more like a needle point. This is really super sharp. Does some really neat things. One of the things that I use it for is stuff like this, breaking these edges down. As you see that little void right there, okay, if you use this burnisher, and if you look at that void as a very, just a very shallow little thing, you can burnish that edge down to where that void is now gone. If you look at the microscopic edge right here where it might catch hair, you can burnish, so you're burnishing, you're pulling metal from the hill, and I'm bringing it down towards the edge. Now, you would not want to do this on a really soft stone. I would want to be careful. Let's say if I was working around opal, I would not, well, here's a piece of opal, and if I can get this in the shine the right way, I can touch this, but if I was to stick this in and pull back, I would certainly scratch it. So it becomes a matter of hardness versus pounds per square inch. This could be a little harder, but polished and not take a direct, super, sharp needle edge and still be fine with it. So you have to be somewhat cautious with that. For a real simple explanation of what it's doing, you can look this way at, just say to take the shank of this. If I was to scratch something with this, the natural thing for many is to begin to abrade out that scratch through a sanding stick or a rubber wheel, and I'll show you some tricks on rubber wheels that help you work on domes. But many would start to abrade out and to remove the upper edge of the metal to come down to the bottom of the new valley that was made by the scratch. But burnishing actually takes the upper edges of the valley and begins to push them back down, so that now the bottom of the valley begins to somewhat fill in. And so that burnishing is in effect what's happening to this edge of this metal. It's being burnished instead of removed. It's being manipulated in that manner. It's good. So we've used a different type of cup burr and some other little tricks, but none of it's going to leave things perfect as far as getting it quite ready to polish. So looking at this prong, there's some things that I see where there's a little bit of flashing. Flashing can be difficult to get with a file, difficult to get sometimes with a graver unless it's really razor sharp, and also somewhat dangerous to do with some of those tools, especially if it's fragile. This micro needle burnisher, used with a very light touch, can be used around some things that are maybe not as tough as sapphire or ruby or diamond, but it could also be annealed, and I'll talk about that. We're going to anneal some tools that will seriously change the hardness of them. I'm going to use this little needle point, just like a sewing needle. I'm going to use that little needle point and just lightly take off that little piece of flash in there, just with the lightest of pressure. You can see cleaned up the majority of that. The uses for this are so many. So now what I'd like to do is show you a great trick about cleanup of the prongs themselves, clean up before polishing. This can be done with different rubber wheels, and when I'm using rubber wheels around something like even a CZ where I could scratch it easily, I like to use a silicone pumice. This is a knife edge silicone pumice wheel, and it's a great wheel for using right around the sides and the front edge of the prongs, especially if this is on something that is not a very hard stone. So very light touch. The thinness of these can be pretty thin. You have to constantly reshape them, and I'll show you that. So just a super light touch can be, I use the knife edge rubber wheel mainly around the front of the prong. And if I didn't have a lot to do in the back, I might touch it up. Let me show you this edge, and it starts to get fat even from that light little bit of work. If you use a diamond dressing stone, you can pretty easily adapt all rubber wheels in shapes that you like by just simply touching them and resharpening. I'm constantly resharpening my rubber wheels. So there is a much sharper version again. One of the things to keep from damaging the edge as much is being very delicate. I think when you get to the front end of a prong, that's time for it to be delicate. I want to show you another great trick for, say, dressing maybe prongs that may be a little taller, a little heavier, or when in working around stones and working around diamonds. This is a great trick. This is using an aluminum oxide abrasive instead of a pumice. The silicone pumice wheel that I just talked about has a hardness of, I think, 4.5. So it's considerably under even opal. Let's take one quick look at that before we move on. Here's an opal, and you can just run this wheel directly on that opal, and we're not having any effect. Opal range is 5 to 6.5, but pumice is definitely softer in the 4s. So here is a pencil cylinder rubber wheel, and this is a little chuck that holds this. This is 3 millimeters in diameter and comes out. You put it in. Many times you'll want to take off the cone to get it in, and then this cone tightens it's a chuck, but it tightens this thing up so you can work with it. Okay. What I'm going to show you today is how to turn this into a little bit of a cup burr for some prongs, and it's just a great trick. So I'm going to take this, and with this diamond dressing stone, I'm going to turn this down into a cone. And this will all be specific to, I think, the size of what I think I need. And then I'll use an older, duller ball burr. And I'll just take, what I mean is I try not to use new ball burrs. I would use an older ball burr. This is pretty sharp, but I generally would use older ball burrs. And I can, while spinning this chuckable piece goes in a flex shaft or a micromotor. While spinning this, I'll by hand apply the ball burr to the end of that. If I sharpen that too sharp, I would just simply flatten it with the diamond stone and then come back. And I'm just gonna make a cup. I don't have to have the exact ball burr all the time because, as you're gonna see here, I'm just gonna pull this a little bit and make it wider. Now, I wanna make sure that I don't pull it all the way out. And if I do, it's an easy fix. It's just, this is like, it happens so fast. Now I've made a little cup. And if I really have to make a prong look perfect on the top, I have to be careful about hitting the stone. But I can take this and come around and put a nice polish, a nice finish, and these come in a lot of different grits on that prong in a way that just has less faceting from using something like a knife edge wheel. I prefer in setting to try to do as much pre-work as possible, but there are certain times when you're setting something where you have to clean up afterwards. You miscalculated, you got to recut a prong and stuff like that. And this is a great little tip, as you can see here. It just does a really pretty job of rounding those. Okay, I want to take just a second to elaborate on some of what you just saw. I introduced Bush's new cup burr. This is the coned version as far as the outside is very slimline and tapered. This can be really nice because it allows you to work around prongs where another prong might be tied up against what you're presently working on. This is Bush's new, it's called a twin cut. There's a lot of burrs out there that I've seen throughout the years, cup burrs, that have slots in them, 4 slots, 1 whole slot across. And this burr is not those. This is a completely different, brand new technology that is just really, outperforms what you would think. So with just these 2 slots, I want to show in maybe slower motion the full effect of the metal spiraling off. And I'm just going to take this prong down. As you can see right here, I have a couple of levels and just want to show you how quick this happens and how efficiently. Okay, so as I'm working it, I want to take a second to slow and just see those continual spirals. That is just optimal cutting, when you can cut metal like that and have it continually flow upwards. So I'll rock it around a little bit like I normally would be setting a stone, but if I just sit right here, just watching such a very short duration, this prong just, we changed the depth, changed the height of the prong tremendously. For those of you with older style cup burrs, I'd like to show you a neat little alteration to them that can really help you when you don't have the right size or you're confined into a tight spot. If you look here by nature, a lot of times the cup burr gets a little heavy and thick on that front edge. And that comes from bumping up against stones and so on, and it gets burnished back. But this technique I'm going to show you is also for if the burr is just slightly larger than what you want to use, you can reduce its size and its accessibility around prongs by just simply doing this one thing. As you can see here, the edge is fat. So I'm going to take this and lay it up on the side of lay it on its side on a sharpening stone. And while running it, I'm just going to run back and forth and begin to bring the side in, making it smaller. And you can see now that that edge is gone, that burnished edge is gone, and actually I'm right there to where the teeth are going to start to just protrude forward of the leading edge. That's a great way to make them smaller, make them fit what you need. One of the next tricks I want to show you is how to deal with something that we've almost all been, situation we've all been put in, and that's a broken drill bit in our metal. When I first started out, I can remember being a little frustrated by this. I didn't know how to drill as well and made little mistakes that caused me to break more drill bits. One of those is pushing down too hard on the drill bit and trying to force more out of it than it's able to cut. That causes the drill bit sometimes to just snap right in half, right in the middle. And that's what I have here. I've got, you can see the drill bit and it's cross section here and it's anchored down in the metal. Can't get it out. It broke down below the metal surface. When I first started as a jeweler 30 years ago, the technique that everybody seemed to say was the thing to do was to let it sit overnight in alum. And alum is a acid used for making pickles, and so it's a mild acid. And I just found that was just took way too long to have to sit and wait on something if you were in the middle of a project. So some years ago, I started using carbide, and carbide, I did a little testing. Carbide's so much harder than what most of our drill bits are made from, and carbide works terrific. So this is Bush's brand new AU carbide. This is something they call it's isometrically centered. It's a completely different carbide technology, and it's considerably harder than just regular carbide burrs. I keep some of these around for just these kind of emergencies. So I'll use a little bit of Burr Life. Just a little bit of oil will help. But you'll begin to see the drill bit just drill up the gray in the drill bit and just kind of eat right through this. Part of the trick is to stay focused on top of, centered up on top of the drill bit, because the metal around it is so much softer. So pulling into it, you can see the gray metal coming up. You'll get to a point where the ball burr sinks in pretty quick, depending upon how deep the drill bit is actually broke off in the metal. This is something you just take your time, but taking that time is a lot faster than the old methods. Almost there. That piece just finally came up in a bigger chunk. Just a little bit more and I'll be ready to finish drilling. I normally clear out in a circular motion the bottom of it just to make sure I got everything that's sitting on the side. You can feel the real difference between what is steel and what is your jewelry metal. Take a good look. I've got it. I'll now take a new drill bit and finish the hole. It was that close to the bottom, but really tough to get out. I'd like to talk to you about a neat little trick that I discovered many years ago. When I first did my first video, bezel and flush setting, I was doing a lot of experimentation prior to that on different hardnesses of metals so that I could develop some specialty burnishers that would help me flush set and very cleanly bezel set softer colored stones. One of the tricks is to just simply anneal regular carbon tool steels. So what I'm going to show you here in reference to some prong setting is how to take an older worn file, and normally that's what I would start with, but this is a mini escapement barrette file, and I'm going to use it around the prongs for the ring that we had set earlier. So if that stone was softer in color, there's always a chance that you could scratch the stone with the file. That's been the downfall of many a beginner, is that in the prong cleanup, after pushing the prongs over and securing the stone, we end up scratching the stone. Very simple way to fix this is a simple quick anneal. So all I'm going to do is put this file on a charcoal block, and I'm going to take a torch and I'm just going to heat it cherry red, and I'm not going to keep it there for any real duration. I'm just going to take it on up and get it nice and hot. And since I might use the file in a full stroke, I'll take it all the way to the end. So I'm finally getting the red that I want. I'll walk that red back. Doesn't have to be, you know, just full on cherry red. The effect is, even though in the lighter red, the effect is there. So I'll show you in just a minute how this doesn't scratch most stones. So here I have an opal that it's been epoxied down to a piece of metal that can be held in a benchmate. And I use this opal to demonstrate with a regular file that has not been annealed how easy it is just to scratch and damage the stone itself. You can hear it, you can see it, okay? So now we'll take the annealed file and we'll try to do that. I want to make sure that you understand that you have to air cool the file when you heat it. If you were to quench cool it, that would actually make it hard again. So I annealed it to the light red color, and then I just let it simply air cool. So here with this file, that you can see it oxidized and see where I heated up to right here, the rest of it normal. And I'll get a nice shiny spot. I'll just go right, that's catching in an old scratch, but right here, I can push on it, I can do whatever I want. Now, pushing at such a concentrated point is dangerous. It really is. It's dangerous because, you know, something that might be slightly softer could damage just via sheer pounds per square inch pressure. But let's take the file like this and look at just file directly on top of the opal, and you can see the burnish mark there, clearly indicating that the opal is harder than the stone. And wherever you file with this, you will get no damage to the opal whatsoever. It's a really neat way to protect yourself. So let's put it to a little practical use for a second. If I wasn't going to use a cut burr, and I didn't pre-finish these prongs prior to setting, I would want to file them. Well, you might think that annealing the file makes it worthless as far as it's not useful in filing, but annealed tool steel is still so much harder than just silver and gold and metals like that. So you can see here it clearly files and clearly shapes the prong. Now the file doesn't last as long, but I'll take my worn files and do this. So I could have a softer colored stone, and I could be working around that softer colored stone with this file with pretty good level of safety and not scratching that stone. Thanks for watching. I hope you found these tips and tricks to be useful. Please feel free to reach out to Rio Grande for questions about tools and techniques that you saw here today. We'd also like your input and comments on future things that you'd like to see us demonstrate. Thank you.